And hopefully I can get some of these recordings up, although I was having technical difficulties, so I'm afraid some of them may not make it. But I will do what I may. And by about 1870, pretty much everybody who studied the matter, with only a few holdouts, is comfortable with the idea that some kind of evolution has happened, that life on Earth, wherever it ultimately came from, which is not really something we're going to have a lot of time to get into, although I do teach another class that will cover that. Wherever life came from, it's changed and diversified and become the life that we see now over a very long historical natural process, some kind of natural process taking place over an extremely long history. And it's possible for science to study what that process is. Just about everybody is perfectly on board with that. The controversy was whether natural selection was the prime driver of that change, or whether it might not be something else. And Darwin's idea of natural selection would not get widely accepted for about another 50 to 60 years. And we have this time period called the eclipse of Darwinism by the evolutionary biologist Julian Huxley. Huxley was the grandson of Darwin's bulldog, Thomas Henry Huxley. He was a noted scientist in his own right, also played roles in doing things like setting up UNESCO, this agency of the United Nations after World War II. Did some things on the diplomatic side as well. So why this eclipse? Well, the objections that were raised at the time were, one, Darwin had always emphasized this very Lyellian idea that evolution happened by very, very, very small changes adding up over millions and millions of years. And it works as long as you have enormous amounts of time. But there were some that argued that the Earth simply wasn't old enough for something as slow as natural selection to have given rise to all living things, from the goo through the zoo to you, as we say, right? From the primordial bacterial slime to all of the animal kingdom, all the way to yourself. And there were some technical arguments that the Earth just simply couldn't be old enough. There wasn't unlimited time that you could draw on. The objection was also raised that if you have a population and some variant appears, maybe it's favorable, maybe a faster bunny or something like that, but that favorable variant, that faster bunny, is only going to have slower bunnies to mate with, and his offspring are only going to have slower bunnies to mate with, so that favorable variation is going to get diluted from one generation to the next. That your favorable variant is going to suffer the fate of a single drop of red paint in a bucket of white, right? It will spread out and ultimately become so diluted that you won't see it. You also have the fact that all that natural selection depends on natural variation, and Darwin had no explanation for what makes organisms vary, where variation comes from, or how it gets passed on. He did some speculation on those matters, and had this idea that he never published, he just kind of toyed with it, that tiny pieces of all parts of the body are constantly breaking off like little buds and passing into the eggs or the sperm. So that basically every time a husband does the with his wife, every one of his sperm contains these tiny little buds of all parts of his body. Her eggs contain tiny little buds of every part of her body, and the buds kind of assemble when the sperm meets the egg, and you get a baby that's a mixture of buds of both. He even suggested that's why husbands and wives supposedly come to look alike after many years of marriage. Because if husband and wife are doing the nasty on the regular, the wife is getting periodic injections of husband buds, and they might be affecting her body and making her start to look like him. So he toyed with that, but really didn't get very far. That's one of the ideas that probably deserves to be, left in obscurity. But nobody else was much better off. Genetics is still this big black box, except for Mendel's one paper, and everybody forgot about that for another 35 years. He published in 1865, but it was mostly ignored until 1900. And then finally, when you think of scientific laws, you often think of things that have predictive value. Isaac Newton and people that followed him, like Pierre Laplace, worked out these laws that could be expressed in mathematics of how gravitation worked. And those are predictive. You can predict where a planet is going to be in its orbit around the sun hundreds of years from now. I mean, we do this all the time. When you send a probe to Mars, we don't launch it at Mars. We launch it at the spot where Mars is going to be in, 6 months or however long it takes. And we can do that because the laws of gravitation have this predictive value. I mean, we've known for years that there's going to be a major solar eclipse visible from central Arkansas. In fact, the path of totality is going right over Russellville in, I believe, 2024. And we know exactly when it's going to happen and how big it's going to be because we can use the laws of gravitation and predict the exact positions of the Earth, Moon, and Sun. The problem with natural selection is that it doesn't seem like that kind of science. It doesn't really have predictive value. You can't look at a living thing and predict exactly what its ancestors are going to look like 1,000 years from now, the way you could look at a planet and predict where it's going to be 1,000 years from now. One of Darwin's detractors was an astronomer named John Herschel. Speaking of planets, he was the son, I believe, of William Herschel, the astronomer who discovered Uranus. If you ever have to lecture on astronomy to a bunch of pre-teenagers, the planet's name is Uranus. Okay? If you ever have to lecture to a bunch of grade school kids, call it Uranus. That's actually close to the Greek pronunciation, and they can't make fun of Uranus and they can't make fun of Uranus, which is much better. Right. Anyway, John Herschel was the guy who referred to natural selection as the law of higgledy-piggledy. Higgledy-piggledy is this expression meaning everything in total confusion. My grandmother would have said iggly-woggly. Some people might say harum-scarum or catter-corner, or, I don't know, total mess, dude. I don't know what your generation says, but higgledy-piggledy means
cringe.
Oh, what's that?
Cringe.
Cringe?
It's cringe.
I thought cringe just meant it was embarrassing.
Well, yeah, I guess John Herschel thought it would be embarrassing for Darwin, so.
Okay, it was cringe for Darwin that it was total mess, dude. Wait, you guys don't say dude now. Fam. Right, okay. Yes, I am clearly totally on fleek here. Trying to speak the contemporary youth slang. Anyway, So it doesn't seem like proper science because it doesn't have predictive value. As we'll see, it can, but in a limited way, but we'll talk about that next week. So a little bit about the detractors. One of them had the unfortunate name of Fleeming Jenkin. He was a Scotsman. He was an engineer. He helped develop underwater telegraph cables. Kind of the proto-internet, as it were, because if you had a telegraph, you could, and you know how to use it, you could carry on conversations with people across the ocean. And people telegraph operators used to play chess across continents and even flirt. It was like the internet's 150 years too soon. Anyway, he helped develop those. He invented these things you might have heard of if you've taken some basic economics, supply and demand curves. And he also pointed out what he felt was a serious flaw in the theory of natural selection. And it comes from what he calls blending inheritance. I'm freaking sick of pigeons, so let's talk about giraffes for a minute. Imagine we have a population of short-necked giraffes. And they are running around, and of course, they're trying to eat leaves on trees because giraffes do that, yes, but they can only eat the low-lying leaves because they have short necks. With me there? All of a sudden, from somewhere, we now call this a mutation. Back in the day, they called it a sport of nature. All of a sudden, a giraffe is born with a long neck. And he never gets to breed because he gets picked on in school. Actually, I'm kidding. He does very well because with his long neck, he can eat all the leaves that the other giraffes can't. So he has lots of food. He's very healthy. Who does he mate with when it's time? One long-necked giraffe and a herd of short-neckers. What are his dating options? Who is out there on giraffe Tinder? Yeah, all of his prospects have short necks. Okay, so he finds a short-necked giraffe and he has babies with her. Assume for the moment that neck length is inherited as a continuous trait. In other words, it's not like a Mendelian trait. Then your long-necked giraffe and his short-necked spouse are going to have medium-necked babies, right? Yes? Okay, well, the medium-necked babies are still doing okay. You know, they can still eat leaves that the short-neckers can't. But when the medium-necked giraffes grow up, who do they mate with? They can either mate with each other if they're in Arkansas. I'm kidding. Sorry. I think I mentioned we make jokes about this in this state. But assuming they're not mating with each other, you know, which very, very rapidly will result in giraffes that play banjo. They only will have short-necked giraffes to mate with, right? Unless they inbreed. And then their babies are going to have medium short necks. And unless they marry their cousins, they're going to mate with short-necked giraffes. And now you have only slightly longer necks and so on. So even if you get one long-necked giraffe, the descendants of that long-necked giraffe are going to have progressively shorter and shorter and shorter necks because that trait will get diluted out because they're mating with generation after generation of short-necked giraffes. The long-necked trait is going to get diluted and eventually lost, kind of like putting a drop of red paint into a bucket of white paint, right? It'll show up fine for a while, but if you stir, eventually that red paint gets so mixed in that you can't even see the difference. Maybe your white paint will be one tiny little shade pinker than it was, but you may not even get to see that. So any variation that's favorable is going to get diluted or swamped out because of interbreeding with members of the population that don't have it. So there's nothing for natural selection to work on. Now, we'll come up with a response to that. I'll mention just briefly that we now know that heredity doesn't work like mixing paint. Since heredity is governed by genes, genes don't blend like that. Instead of mixing a drop of red paint in a bucket of white, heredity would be more like putting a red marble into a bucket of white marbles. The red marble might be hidden, but it's not permanently lost. All right, it doesn't dilute. You don't make a red marble whiter by dropping it in a bucket of white marbles. And genetics works more like mixing marbles, or we'd say now alleles, than by mixing paint. But I'll get to that later. There was an even more formidable opponent. It was this famous Scotsman by the name of William Thomson. Thomson pretty much invented modern thermodynamics. Worked out a lot of the physics of heat transfer and things like that, used it to design more efficient steam engines, and became so famous that he was made a noble, and he took on the title of Sir William Thomson, Lord Kelvin. Right, he was just born Willie Thomson, but Kelvin is what they called him after he became a baron of the United Kingdom. And I know you've heard of this guy because they named the temperature scale after him, right? Yes? Okay, that's a pretty big mark of respect to have a temperature scale named after you. And Kelvin argued, based on the physics of heat transfer, of thermodynamics, that the Earth was not indefinitely old. The limitation of geological periods imposed by physical science does seem sufficient to disprove the doctrine that transmutation has taken place through descent with modification by natural selection. Sorry about the accent. So what does he mean by this? We know the Earth is hot on the inside. Evidence A, volcanoes. Evidence B, the deeper you go down in a mine, the hotter the temperature gets. The deepest mines on Earth are some gold mines in South Africa, and I want to say they go down something like 2 miles. And they have to be cooled by this very expensive air conditioning system. That, like, you have to constantly pump ice water down 2 miles into the Earth to run this cooling system. And even with the cooling system, it's pretty miserable to work down there. If it wasn't for the cooling system, you couldn't work in there at all. It just gets hotter and hotter the deeper you go. So we know the Earth is hot on the inside. We know that it increases with depth. Roughly 25 degrees Celsius per kilometer, or 1 degree Celsius every 40 meters. So we know the Earth is hot on the inside. It's fairly cool on the outside. And we know that a warm body that's floating in space radiates that heat away to space at a rate that's governed by the laws of physics. Everything that's above temperature of absolute 0 is giving off energy. You're giving off energy right now, although not in the form of much visible light, but you're giving off infrared. And in fact, if I had night vision goggles that detect infrared, I'd see you all glowing, right? You've seen that? Or maybe you've seen thermal cameras that do the same thing. Yeah, anything that is warmer than absolute 0 gives off some amount of energy. And since energy can't be created or destroyed, that means everything that's warmer than absolute 0 must be cooling down. Right? With me there? It's cooling down because it gives off energy. If you want the details, look up what's called black body radiation. That governs the type of energy that's being given off. Okay, so we know the Earth has a current temperature, or a current temperature gradient anyway, and we can calculate how fast it must be given off heat into space. And Kelvin concluded that if you take those facts and you plug and chug, the Earth must have been molten relatively recently. It wasn't super long ago that the Earth must have been so hot that the surface rocks would have melted and the Earth would just be a big ball of lava. You know, like Mustafar in Star Wars Episode 3. And evolution is not likely to take place on a lava planet because nothing can survive in lava. So all of biology, all of biological evolution must have happened once the Earth cooled down enough to have a solid crust, right? Yes? And Kelvin tried to estimate how long ago that had been. The math still was not very accurate because some of the physics wasn't all that well known. But Kelvin's best estimate that the Earth had to be older than about 20 million years, but younger than 400 million years. And it's not mentioned in this quote, but he thought it was closer to 20 million than 400 million. If the Earth was older than 400 million, we wouldn't have any internal heat and there would be no volcanoes and you know, no increased heat as you go down in mines. The Earth wouldn't have any heat left at all. If it was younger than 20 million, the Earth might not have cooled enough to have a solid crust. So that finally tries to put a limit to the amount of time that you've got. And 20 million years does seem like an awfully long time, but it's still, Kelvin argued, not enough for life to originate as some kind of primordial germ or something, and for that germ to give rise to everything, you know, from amoebas all the way up to Kim Kardashian. Sorry, I was trying to think of the most advanced life form I could think of. And,
Kim Kardashian.
maybe a bad choice. Maybe a bad choice. Yeah. How do you get from like primordial germy things to Kim Kardashian in 20 million years? Kelvin argued that you couldn't. Huxley tried to defend Darwin's ideas and argued that, you know, Kelvin didn't have solid enough estimates of the amount of heat of the Earth to really make any estimate as to how old the Earth was. Kelvin's formulas were very accurate, but if you plug bad data, it doesn't matter how good your formula is. If you plug bad data into it, you're going to get flawed results, right? Like computer programmers used to say, GIGO, garbage in, garbage out. Right? As the grandest mill in the world will not extract wheat flour from peas, pages of formula will not get a definite result out of loose data. Still, Kelvin was a guy to be reckoned with. I mean, he's one of the most respected scientists in the world. Like, you know, they named the absolute temperature scale after the man. If it helps, in his old age, Kelvin came to be kind of a stick in the mud because he claimed things like, I used to have a slide showing this. In his later years, he came to claim that heavier than air flying machines were impossible, radio was useless, and X-rays were a hoax. He also came to claim that life on Earth was not going to last longer than about another 200 years. And the reason was he estimated the amount of oxygen being produced by all of the plants in the world. And he calculated the rate at which oxygen is used by the metabolism of all the animals in the world and worked out that we were going to run out in 200 years. I should mention, by the way, that the math was perfectly good. He did not get his math wrong at all. What he missed is the fact that most of the oxygen in the atmosphere isn't produced by land plants, it's produced by microscopic algae in the oceans. Some of them only 1 micron in size, so tiny you can't see them under a light microscope as anything more than a dot. And yet they exist in such incredible numbers that they generate more oxygen than all of the land plants do. So you'll see this again. The math was perfectly right, but Kelvin missed something. So anyway, if you've got people like Fleeming Jenkins saying that inheritance is natural selection can't work because variation gets swamped out, and Kelvin arguing that the Earth's not old enough to fit all of the scope of biological evolution from the first primordial cells all the way to Ed Sheeran. Is that a better choice than Kim Kardashian?
Better.
Okay. All the way to Fleur Janssen. You don't know who she is? Oh, the lead vocalist for the Finnish heavy metal band Nightwish. Grinding heavy metal with a female operatic lead singer. It freaking works. They actually did a recent album that's a tribute to evolution and Darwin. We've got a great song called Endless Forms Most Beautiful. And it freaking shreds, man. Anyway, so how did everybody react? Well, Alfred Russel Wallace, the co-discoverer of natural selection, kind of annoyed all of his friends because later in his life, he got really involved in spiritualism. Meaning in this case, attempts to contact the souls of the dead. So he went to a lot of seances, where mediums, you dim the lights and then you hear ghostly voices or spirits start rapping on tables, things like that. And he became convinced that you could use natural selection to explain the evolution of everything except human nature, because that was down to the human soul, which could not be explained by science at all. As he put it, there was a subsequent act of creation, a giving to man when he had emerged from his ape-like ancestry of a spirit or soul. Nothing in evolution can account for the soul of man. The difference between man and the other animals is unbridgeable. So a number of scientists could accept evolution up to a limit, but then you have to invoke something else, maybe God, maybe, I don't know, wherever souls come from, to explain major changes. Huxley actually used to argue this point with Darwin. Like I mentioned, Huxley was a supporter, but he wasn't a mindless Darwin fanboy. Because Huxley argued that you might get change in a species by large-scale changes in one generation. Darwin had always emphasized this very plodding nature of natural selection, adding up tiny changes over long periods of time. Huxley argued that you could get inherited genetic change on a larger scale in a single generation. That's a theory now called saltation, from the Latin word for to jump, saltare. I don't know if it's in Portuguese, but it's saltar in Spanish.
Salta.
Saltar in Portuguese? Okay. Yeah, saltation. Sorry?
We don't really use it.
Okay, but it does exist. Okay, saltar means, I think they still use it in Spanish. It means to jump. You could say brincar in Spanish too.
Brincar, like play.
What's that?
Brincar, like play.
I think in Spanish that's jump, but maybe in Brazil you jump a lot when you play. Okay, whatever. Right. So yeah, here he writes a letter remembering that He used to advocate the possibility of considerable saltus, meaning jumps. He always took that view, much to Mr. Darwin's disgust, and we used often to debate it. So maybe the evolutionary change is not slow and gradual and continuous, but you can make some leaps. Interesting idea. We'll come back to that. There was a whole school of people who rediscovered Lamarck's work, and the advantage of Lamarckian evolution is it happens fast. Organisms are basically able to make themselves change in adaptive ways. And so Lamarckian evolution, if it happened, would be able to happen a lot more quickly than natural selection would. And in his later years, he accepted a greater role for Lamarckian evolution. Darwin was not a strict Darwinian. That's a quote from Origin of Species. Something, perhaps a great effect, may be attributed to the increased use or disuse of parts. We talked about Lamarck on the first day. Make sure you get the notes, because yeah, 2 people weren't here on that day. So by about 1900, just about everybody is fine with the idea of some kind of biological evolution. At best, natural selection might be one mechanism among many. At worst, it might be only a really minor thing, and something else must be causing all of that change. And this is not religiously motivated opposition, be it said. These were fellow scientists, some of the best minds in the West at the time, who were raising some very valid objections. So, yeah. But I'm going to keep you in suspense, and we'll look at that yeah, but when we reconvene tomorrow. All right, tomorrow we'll see how natural selection managed to emerge from the pack and become the leading theory for what causes change. And I will now stop recording.